I'm Terry from Final Project Team 11, and for our project, we built Quade with the MSP432 as its base, and then we can control it wirelessly by a remote control with a 2-axis joystick. So for the remote control, we use the Arduino Uno or Redboard as its base, and a 2-axis analog joystick as its input, and then we convert those analog data and output them to the RF link transmitter via UART, and then that will transmit to the RF link receiver via ASC. And then the MSP will then read those values via UART. And then we create a finite state machine for the MSP that has different states for reading data and then writing data to the servos. So to write data to the servos, we communicate with the PCA chip via I2C in order to output PWM signals to the servos in order to move Quade. Then also we connect the thermistor to the MSP and use the ADC on the MSP to convert the output value from the thermistor in order to control the onboard LEDs based on the ambient temperature.
Just briefly going over a schematic for our Arduino Shield PCB design. We implemented a joystick, which can be seen right here, which is then directly connected to the Arduino Uno Shield. We also connected the RF linked transmitter to the Arduino Shield and then have an antenna to transmit the data to the RF linked receiver. Going over to the PCB layout, you can see that we have all the same hardware. We have the voltage source right here hooked up to the Arduino Uno Shield, and then we have the joystick and then the RF link transmitter sitting on top of the shield, and then we have the antenna right here.
Debug this. So we're going to be using the analog discovery 2. So the only difference here is that we're going to take out the receiver transmitter, and we're going to use the analog discovery 2 to see what the Arduino is giving out. So we're going to read it with a logic analyzer, and then we made our own UART code that we're going to send to the MSP432 to test it. We're also analyzing the joystick voltages to see how those change as well. So as you can see here on this screen, on the top one, we have the oscilloscope, and let's see if you can see, if I move the vertical axis on the joystick, you can see the voltage changing. So if we have 5 volts, it's going to cut it in half, so it's going to be at 2.5, and then full throw to the north would be 5 volts, to the south would be 0 volts, and then for the horizontal, full throw to the west is 5 volts, and to the east would be 0 volts. So we can see that our joystick is working. I don't have the switch set up, but trust me, it does work. And then on the bottom here, we can see this is what the Arduino is giving us. So if we stop that for a second, you can see that it's in, let's get a good one, it looks like. It's giving us UART, so it's going to have a start bit, 8 bits, and then a stop bit, and that'll be our analog to digital code that it's giving out for the values of the joystick. So we can see that it's working. We're using a joystick to give us voltage, and then we're getting out UART data. So then looking into to test the MSP432, what we did is made some test sample UART data in a pattern generator, and it's just the same thing that the Arduino should be giving out, and that's getting put into the receiver pin on the MSP432. So now when we go into debug mode over here, with the code, we can put a breakpoint on the IRQ handler, run the code, and look, now we're putting the UART pattern on the pin, and then it popped into our IRQ handler, which means now that the UART is receiving something. Then we can see down here, we put another, we can see what the receiver value is. So that's 4, right? And then we can just kind of go through this and it changes. So 2, 0, and these are the values that we were giving it. It's not always the same just because I can't click as fast as the UART's going. But it's giving me these bytes that we're sending, and these were the actual bytes that were being sent. So it's verifying that we're using the joystick to give the Arduino a value. That Arduino is then taking that value, transmitting it through UART to the MSP. The MSP's picking up that UART, parsing out as we need it, and then giving us that value. So minus the actual hardware of the transmitter receiver, the code is working properly.
This is the thermistor circuit. It consists of a 10K ohm thermistor and a 10K ohm resistor to form a voltage divider that then sends an analog signal to the MSP. From the MSP, it goes through an analog to digital converter, which will then send a digital signal, which will output the LED color. Inside the debugger, we found the register for the analog digital converter and is currently set at 1DD1. The hex value translates over to a digital value of 7,633. Going over to the thermistor diagram, we can see that lies between these values, which translates to a temperature between 20 degrees Celsius and 25 degrees Celsius. And checking a thermometer, it is indeed 22 degrees Celsius. So the thermistor circuit is indeed working. I have currently cooled down the thermistor to below freezing, 0 degrees Celsius, and it is showing the color white. It kind of looks pink, but that is white. I will now use a small space heater. See, it already has gone up to blue, which is between 0 and 10 degrees. Oh, it's now gone between 10 degrees and 20 degrees Celsius. I will now use a small space heater to heat it up to try to get it above 40 degrees Celsius.